So we continue and consider some examples. Okay, so now the example, okay, describe all points xy in R, okay, where R is a closed region in two-dimensional. Okay, two-dimensional here meaning that of course two-dimensional here meaning your closed region in xy plane. Okay, in the xy plane. Okay. So I just put here xy. Okay, first let's consider first example. Okay, now let me my R. Okay, my R is region. Okay, region bounded. Okay, bounded by the coordinate. Okay, coordinate axis. Okay, coordinate axis and x plus y is equals to 2. Okay, okay, so now we want to describe all points, okay, in R, okay, where R is a region bounded by the coordinate axis and x plus y is equals to 2. Okay, first let's sketch our R. So our R in the xy plane, okay, since our R in the two-dimensional, okay, so we have y and x. Okay, okay, so now our R is region bounded by the coordinate axis. What the meaning of coordinate axis? Coordinate axis meaning that x equals to 0, y equals to 0. Okay, so x equals to 0, this axis, y equals to 0 will be this axis. Okay, and x plus y is equals to 2. Okay, what the meaning of x plus y equals to 2? So this is just a straight line. Okay, straight line, meaning that if my x equals to 0, then my y is equals to 2. If my y is equals to 0, my x equals to 2. Okay, so we will have this straight line. Okay, so we have this straight line. Okay, so this one will be x plus y is equals to 2. Okay, this straight line. Okay, so where is your R? Okay, where is our R? Okay, our R will be inside here. Okay, since our R here is closed region, okay, and bounded by coordinate axis and also this straight line. Okay, so this one will be my R. Okay, so inside here. Okay, so now we want to describe, okay, all points in R. Okay, all points in R. Okay, since just now, okay, we already discussed that we can describe our all points in R by two approach. Okay, by two approach. Either one, okay, either you want to see okay, either you want to see your R from the x-axis first, okay, or you can check by using second approach. Okay, where the second approach you see first the closed region here with respect to y-axis. Okay, okay, of course you can choose either one. Okay, you can choose either one, which approach that much easier for you. Okay, much easier for you to describe all points in R. Okay, meaning that you doesn't need to describe by both approach at the same time. Okay, so you can choose either one. Because of what? Because it just give you the same thing. Okay, it just give you the same answer. Okay, either you describe by first approach or second approach. Okay, so the result, okay, the answer should be the same. Okay, Otherwise, if you do some mistake, some wrong, this one is this one is another thing lah. Okay, but if correct, meaning that for example, if you use the first approach, okay, and then you correctly describe all points in R, so it follows that for the second approach should be correct. Okay, so meaning that no need. No need to check for both approach. Okay, only choose one. Okay, and then choose for easy for you. Meaning that choose that easy for you. Okay, which approach? Okay, so now from here, okay, my R. Okay, so now let's describe all points in R here. Okay, all point in R. So now I need to find such a point from R2 here. Okay, from the two-dimensional. Okay, with condition. Okay, with some condition of my X and my Y. Okay, for example, in this R here. Okay, I will check for X first. Okay, I will check for X first because for me, it's easy to check this R here. Okay, first by looking along x-axis. Okay, so when we see along x-axis, now we see that our R here, okay, in between which values? Okay, so since this one is 0, okay, because this one is minimum one 0, and of course the maximum one they will go to 2. Okay, therefore from here my condition for x is between 0 and 2. Okay, 0 and 2. Okay, my x here, if you see, my x here in between 0 and 2 because 2 also include, and then 0 here is include. Okay. Okay, now the next thing I need to find the condition for y. Okay, condition for y. What the meaning of condition of y here? Meaning that now I need to see my R here along y-axis. Okay, so of course we need to start from the below because the below is the less value of my y, and then we go upstairs. Okay, we go to upward here. Okay, so now you see it will come to this part. Okay, to this point, and then it will go up to this point. Okay, of course my y here, what is my y value of my y here? Okay, my y here is equals to 0. Okay, how about this line? Okay, this line will give me y is equals to 2 minus x. Okay, therefore the condition of my y here I will have in between 0 and 2 minus x. Okay, of course this function here, okay, need to depend on x. Okay, so this is the first answer. Okay, how I can describe all points in R. Okay, for the first example. Okay. Okay, let's consider the second example. Okay, let be R. Okay, let be R. Okay, R is bounded, okay, by x equals to 0, y is equals to 2x, okay, and y is equals to 4. Okay, so this one. Okay, let's consider the second example, and we want to describe all points in R. Okay, the second example. Okay, so let's sketch. Okay, let's sketch first your R. Okay, always remember. Okay, when we want to describe all points in R here, always start with the sketch. Okay, because after you sketch, then you can see the condition for your X and Y. Okay. Okay, X equals to 0. What do you mean of X equals to 0? Okay, X equals to 0. Okay, this exists, right? Okay, X equals to 0. Y equals to 2X. What do you mean of Y equals to 2X? So you have the straight line. Okay, you have this straight line. Okay, Y is equals to 2X. Okay, and then we have Y equals to 4. Okay, Y equals to 4. So you have 4 here. So you only have this straight line. Okay, this straight line. Okay, so this one. Okay. Okay, R is bounded by X equals to 0, Y equals to 2X, and Y equals to 4. Okay, of course, our R here is closed, meaning that this one will be our R. Okay, so this one will be our R. Okay, so this one is my R. Okay, close it here. Okay, so now let's describe all points in R here. Okay. Okay, so I will describe my R, X, Y. Okay, so meaning that I need to find all the X, Y from R2. Okay, with condition. Okay, condition of my X and also condition for my Y. Okay, so from here I will use the second approach. Okay, I will use the second approach. It's much easier. It's much easier for me. Why? Because I already have Y. If you can see, I already have Y equals to 0 and Y equals to 4. Okay, Y equals to 0 and Y equals to 4. Therefore, I will start with the condition that along Y axis. Okay, meaning that my Y here is in between 0 and 4. Okay, it's something like okay. If you cannot see how I can get my Y here from 0 to 4, maybe you can just take this graph and then rotate it. Okay, you can rotate it. Okay, you can rotate it, and then you can see that your Y here in between 0 and 4. Okay. Okay, next I need to find my X here. Okay, the condition for my X here. So where I want to find the condition for my X here, now I need to see my R here along X axis. Okay, along X axis. Meaning that, of course, I need it to take from the left part. Okay, because the left part is the less values of X. Okay, so now from the left part, go to the right part here. Okay, so it will come to this line, and then it will go up to this one. Okay, it will come to this function here. Okay, this value, and then it will go up to this value. Okay, so what is the value here? Okay, so this one is X is equals to 0, meaning that X here should be in between between 0. Okay, now it will go up to this one. Okay, of course this one will be this straight line. Okay, will be the straight line here. So what is this straight line here? So since I have Y is equals to 2X, meaning that I will have X is equals to Y over 2. Okay, so meaning that my X here should be in between 0 and Y over 2. Okay, this one. Okay, of course this one should be what? Should be a function depend on X, right? Because of what? Because for this part, for this condition, you are looking the R here along X axis. Okay, so this is by the second approach. Okay, because you have X, meaning that you need to have some function depend on Y. Okay, so this is the second example. Okay, let's consider the last example. Okay, the last example from our discussion here. Okay. Okay, so let's consider the last example. Okay, so the third example. Okay, let me my R here. Okay, it's a region. Okay, bounded by x equals to minus y squared, and y is equals to x plus 2. X plus 2. Okay, so this one. Okay, third example, we want to describe all points in R, where R is a region bounded by x equals to minus y squared and y is equals to x plus 2. Okay, so let us first sketch this R. Okay, sketch our R here. Okay, now let's first sketch what is x equals to y minus y squared. Okay, x equals to minus y squared. Okay, if you cannot remember how to sketch this curve, okay, I will ask you to recall back, okay, from your previous course. Okay, so x equals to y squared. Okay, so meaning that first let's look what is the meaning of x equals to y squared. X equals to y squared, then you can sketch by this way. Okay, but since you have minus, then you have minus, so you will have this one. Okay, so you have this one. Okay, x equals to minus y squared. Okay. Okay, the next thing, y is equals to x plus 2. What do you mean y equals to x plus 2? Y equals to x plus 2, meaning that you have a straight line here. Okay, so you will have this straight line. Okay, of course you need to let this line from minus infinity to infinity. Same with this parabola from minus infinity to infinity. Okay, so now you will have something like intersection here. Okay, you will have something like intersection here. Okay, so now where is your R? Okay, so my R will be this part. Since my R here is close, right? Okay, so this one. Okay, so this one can just write. So this line will be y is equals to x plus 2. Okay, y is equals to x plus 2. Okay, this line. Okay. Okay, so now let's describe all points in R here. Okay. So my x, y should be from R2. Okay, so now I need to find the condition for my x and also for my y. Okay. Okay, so which one is easier here? Okay. Okay, since I have a x equals to minus y squared, okay, and of course from here y is equals to x plus 2. So therefore this one is not it's not a problem for me to find x here, right? Okay, from here it's easy for me to find my x here. So I will have x is equals to y minus 2. Okay, so this one I can write something like this one. Okay, so now I have something like x equals to y minus 2, x equals to minus y squared. So from this example here, okay, it's easy for me to find first the condition of y. Okay, why? Because okay, why it's easy to find the condition for y first because of what? Because y here we need to find such of values. Okay, y here should be in between which values? Okay, because now we have x in terms of function here, right? Okay, for example, x equals to minus y squared, x equals to y minus 2, meaning that you can put in the second condition here, my x here should be in between these two functions. Okay, but of course the first thing you need to find the condition of my y here, since my y here should be what? Should be in between some two values here. Okay, so how we can find the condition of my y here? So the condition of my y here will be Okay, meaning that I will see my R here with respect to y-axis. Okay, with respect to y-axis, since you have these two intersection point, right? So I have this point and I have this point. Okay, so I have this point and I have this point. So meaning that my R here should be in between these two values. Okay, so this one and also this one. Okay, so now we need to find the value of this one and the value of this one. Okay. Okay, so how to find this value? This one and this one. Meaning that since these 2 points is the intersection between these two curve. Okay, these two curve here. So now I will have, okay, since x equals to minus y squared, y is equals to x plus 2. Okay, or this one. Okay, y minus 2. So I can find the intersection point by equal of it. Okay, equal between them. Okay, equal between them. X. Okay, so we have minus y squared is equals to, so x minus y squared is equals to y minus 2. Okay, so from here I will have y squared plus y minus 2 is equals to 0. Okay, so you can solve this. We can solve this quadratic equation, and then we can find my y here is equals to what? My y here will be equals to so my y here will be equals to what? Okay, so I have minus 2 meaning that, okay, so my y here will be equals to minus 2 and y here is equals to 1. Okay, so this one. Okay, so we solve the quadratic equation, and then we get that my y here is in between negative 2 and my y here is equals to negative 2 and my y here is equals to 1. Okay, of course this value will be, okay, negative 2, and then this value will be 1. Okay, this value will be negative 2 and this one value will be 1. Okay, because I find the intersection point here, right? It is intersection point, and then we check for the value of our y. Okay, so my y here between is equals to minus 2 and 1. Okay, therefore my y here is between 1. Okay, since we check our r here in with respect to y-axis first, right? Okay, it should be from the lowest value to the greater value here. So this one should be minus 2, 1. Okay, my y here should be in between minus 2 and 1. And of course my x. How to find my x here? Condition of my x. Okay, my x here should be from left to the right, right? Okay, from left to the right. Okay, it will go to this point. Okay, this point will correspond to this line. Okay, and then it will go to out from this point. Okay, this point will correspond to this curve. Okay, so what is this one? Okay, this one is actually y minus 2. Okay, y minus 2. Okay, how about this one? This one will represent this part. Okay, so this one is minus y squared. Okay, so this one will be the answer. Okay, of course, the important when you want to find the condition for x here, please make sure that the function here should be depend on y. Okay, depend on y. Why? Because this condition with respect to x-axis. Okay, with respect to x-axis, of course, you need to find this part. Okay, a function with respect to y, and this function also with respect to y. So therefore, we have this condition. Okay. Okay. So, okay, always remember, when you want to describe all points in R here, please make sure that you need to sketch your R. Okay, you need to sketch the R here. Okay, why? Because when you sketch the R, now you can see how you can control the condition of Y and the condition of X, for example here. Okay, because of that, it's very important to sketch your R first. Okay, the idea here, you just want to find the correct answer correct condition for y and correct condition for x. Okay, because maybe we have a problem if we don't sketch the r here. Why? We don't know. For example, this x, right? We don't know this x here should be in between which function. Okay, we might do some mistake. Okay, we might do some mistake when we choose our x here in between minus y squared and y minus 2, for example. Okay, of course this one is not correct. Okay, this one is not correct. This one is wrong. Okay, because of what? Because you see from our sketch here. Okay, our sketch here, it shows that our x here should be from y minus 2 to minus y squared, in between y minus 2 and minus y squared. Okay, because of that, it's very important to sketch first your r. Okay, to sketch first your closed region here. Okay, just to avoid some mistake. Okay, when you want to find the condition for y and condition for x. Okay, for example this one, or either one. Okay, either one meaning that if you want to find first the condition for x and then the condition for y, of course you need to sketch your r. Okay, you need to sketch your r. Okay, to avoid some mistake. Okay, that will be done. Okay, when you choose the condition for y and for x and y. Okay. Okay. So before we end, okay, so I will give you two more. Okay, I will give you two home tasks. Okay, let be this one is another two examples. Okay, but I will not show you the example, these two examples here today. Okay, I will ask you to try to study by yourself. Okay, let be this one is your home task, and no need to submit. Okay, no need to submit. But if you want to check the answer with me, okay, you can do. Okay, just send your answer here to my Telegram. Okay, I will check on the spot. Okay, either your answer is correct or wrong. Okay, so let be these two examples here. Let be your home task. Okay, no need to submit. But if you want me to check, you can just send to my Telegram. Okay. Example number 4. Okay, let me this one home task. Okay, describe all points in R. Okay, where R here. Are here. Okay, it's bounded by, okay, y is equals to exponential x here. Okay, y equals to exponential x, y equals to 0, x equals to 0, and x equals to ln 2. Okay, this one. Okay, x equals to ln 2. Okay, what is the meaning of x equals to ln 2? Ln 2 here is just a number. Okay, just a number. So x equals to ln 2 meaning that it's just a straight line. Nah? Okay, it's just a straight line here, right? Okay, it's just a straight line. But at the number ln 2. Okay, of course y equals to exponential x here. Okay, so this part. Okay, this curve you need to recall back how to sketch this one. Okay, y equals to x. Okay, and then example number 5. Okay, let me this one is your home task. Okay, I will suggest you to do this this home task. Okay, this home task, so you can hopefully you can understand more. Okay, understand clearly. Okay, how we can describe all points in R here. Okay, because this is very important. You need to understand this first. Okay, later if you already understand very well how to describe all points in R here, so it's not a much problem. Okay, to deal with the for example, to deal with the double integration. Okay, double integral, we will use this one. Okay, we will use this discussion. Okay, so therefore I ask you in this 1 week, please make sure that you understand how to describe all points in R here. Okay, by checking the condition for X and Y. Okay, let be example number 5. R here is bounded, okay, bounded by X is equals to Y minus Y squared and Y is equals to minus X. Okay, so this one. Okay, so let be this one is your home task. Okay, you can try to do by yourself. Okay, consider it as a 4th example and 5th example. Okay, no need to submit, but if you want to check either the answer is correct or not, okay, you just can send me your answer. You can just capture and then send through Telegram, and then I will check on the spot. Okay, after I read the message. Okay. 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 Of course, I will ask you to check to describe here. Okay, by using either one approach. Okay, you don't need to present both approach. Okay, just choose one approach. Okay. We already discussed how we can describe this point by 2 approach, right? Okay, but I will not ask you to present these 2 approach. Okay, just choose one. Okay, which one is much easier for you? Okay, which one is much easier for you to describe all points here in R? Okay. Okay, I think for today, okay, we stop at here. Okay. So in the next class. Okay, so in the next class we will begin, okay, our second part, okay, of our course. Okay, so second part of our course, okay, we will discuss about multiple integral. Okay, about multiple integral. Okay, multiple integral. Okay, so in this second part, okay, multiple integral here will cover only 2 types of integral. Okay, will cover only 2 types of integral, double integral and triple integral. Okay, triple integral. Okay, only this one. Of course, we have something like 4th integral, 5th integral, 6th integral, and so on. Okay, but of course, in our course, we just consider only the simple one. Okay, in the lowest dimension. Okay, so we consider double integral and also triple integral in our course. Okay, of course, in your previous calculus course, okay, you already introduced. Okay, you already considered single integral. Okay, single integral, and I hope that all of you still not forgot about how to evaluate the single integral. Okay, so after this we will discuss. Okay, we will discuss about this topic. Okay, about the double integral and also triple integral. Okay, we just extend. Okay, extend the integral here from single. Okay, in your previous course. Now come to this course. We will have the concept of double integral and also triple integral. Okay, I will use the textbook. Okay, I will use still. You can continue the textbook. Okay, Thomas Calculus. Okay, Thomas Calculus. Okay, I will use this textbook, Thomas Calculus. Okay, so in this Thomas Calculus, for the partial derivatives, covered chapter 14. Okay, for multiple integral, we will cover chapter 15. Okay, chapter 15. Okay, so this will be your textbooks, huh? Okay, textbooks. So multiple integral here, I will use the Thomas calculus, and only chapter 15. Okay, chapter 15. Okay. Okay, so next week we will come to our main topic. Okay, our main topic, and we will begin with the double integral. Okay. Okay, so that's all. Okay, so I will see you next week.